The concept of energy in astrophysics, in my opinion, we can divide that into two major categories. The energy from astrophysical entities and astrophysical systems, and the energy that we spend to discover those astrophysical systems. The biggest energy and the most familiar one, astrophysical system, is the energy we get from the sun. Without the energy from the sun, we would not be here to discuss the topic of energy. The energy from the sun is extremely important to make life exist and sustain on Earth, Earth being habitable. But aside from that, it has its own drawbacks as well. It creates environments that are dry, that are not habitable, they are not hospitable to farming, and all that stuff. It has its own good and bad. In addition to that, other astrophysical systems that give energy is like stars. When they reach the end of their lives, these stars explode, and that energy gets scattered all over the galaxy. Now, one may say that when the stars explode, that's the end of it, whereas that is not. That energy, the energy that comes from exploding stars, triggers formation of new stars in rims of the galaxies, and those new stars will have planets, and those planets will have habitable planets, and they use the light from their suns to be habitable. And there are others like gamma ray bursts and quasars, and like for instance the recent discovery of the ripples in the space-time due to gravitational energy. So you can name all these different types of energy in astrophysics, but the most important thing is that in order to discover them, we have to spend energy on telescopes and that the energy that is spent on telescopes, they are man-made energies. They are energies that are produced in form of the electricity by electricity producing plants, and that goes into the discovery. It goes into running a telescope and making the discovery of these objects. So one may say that, well, in order to understand the energy that comes from astrophysical systems, you are wasting energy, and that is actually a question that I would like to answer. I would like to address in a little bit more in-depth approach. That the purpose of spending energy to discover these astrophysical systems is not for mere discovering them. It's not like to go there and say, "Oh, I discovered a piece of rock. I discovered a gamma ray burst." There are fundamental scientific questions behind them that when these discoveries are made, especially when many of them are made, either they confirm our understanding of the universe and the way that universe, planets, stars form, or they bring up questions that then guide the theoretical investigations into that. Now, why is that important? You may say that, well, why would that understanding the explosion of a star be important? Well, by itself, it answers some fundamental physics question, but when we have the collection of this knowledge and we pass that to the next generation and the next generation, the way that this passing of the knowledge sets up their minds, the way that it brings them up, the way that they learn how to think, results into people who are capable of making right decisions, making instruments, making equipments, and making things that make energy less expensive, more affordable, and also less wasted. In other words, it is not just wasting energy to discover a planet, it is the knowledge that goes into training students, the future engineers who will help us to maintain our system, our Earth, our planet to be green.